Numbers, tables, and endless spreadsheets. Handling data can feel like an impossible puzzle, but not with Pandas. This incredible Python library transforms messy data into clean, organized structures. Welcome to day 2 of the 30 Days of Machine Learning series. If you missed day 1, don't worry. You can click right here to catch up and start from the beginning of this exciting journey. Before we dive in, don't forget to hit that subscribe button so you're always up to speed with the latest videos in this series. In this video, we're unpacking the magic of Pandas. You'll learn how to manage, manipulate, and analyze data effortlessly with DataFrames and series, and see why Pandas is the go-to library for data science and machine learning. So, whether you're struggling with inconsistent data or just looking to level up your skills, stick around. By the end, you'll be equipped to handle data like a pro and have fun doing it. We're importing Pandas for data manipulation and NumPy for numerical operations. Creating a Pandas series with numbers and a NaN value. Ready to explore its functionality. This generates 6 sequential dates starting from January 1st, 2025, using pd.dateRange for time-based indexing. Here, we're creating a data frame with random numbers, indexed by dates and labeled columns A to D. Creating a data frame with diverse data types, floats, timestamps, series, categories, and even strings. Using df_head to view the first few rows and df.tail3 for the last 3 entries. df.index reveals the row labels, while df.columns shows the column names of our data frame df. To numpy converts the data frame to a numpy array, and df_describe gives statistical insights. dft transposes the data frame, swapping rows and columns for a different view of the data. This sorts the columns in descending order based on their labels. This code sorts the rows based on the values in column B, in ascending order. df A selects column A, while df 0 to 3 slices the first 3 rows of the data frame. This code selects the row corresponding to the first date, and this one grabs the value in column A for that date. Here it fetches as same as previous one, while this code selects the 4th row by position. This code slices rows 3 to 4 and columns 0 to 1 by their integer positions. Selects specific rows 1, 2, and 4, and columns 0 and 2 by index. This code selects the 2nd row, index 1, across all columns of the data frame. Creating a new series S1 with values and dates as the index, perfect for time-based data. Assigning S1 to a new column F in DF, aligning the data by index automatically. This code updates a specific value by label, and this one modifies a value by position. Setting all values in column D to 5, using array broadcasting. df reindex allows us to add missing rows and columns. Here, adding column E and adjusting rows. Here, we're filling column E with 1 for the rows between the first two dates using df1.lowc. Removes rows with any missing values and filling missing data with 5. Checking for missing values in df1, returning true for naians and false otherwise. dfmean calculates the mean of each column, while this one computes the mean across rows. Shift 2 shifts the series by 2 periods, moving values forward and introducing naians for the shift. Subtracting the series S from the data frame, aligning data by index. This code applies a custom aggregation, while this one scales the data frame values with a transformation. Counting the frequency of each unique value in the series, giving us a quick distribution overview. Converting all string values in the series to lowercase, making text uniform for analysis. Here, we're splitting the data frame df into 3 pieces and then using PD concat pieces to combine them back together. We have 2 data frames, left and right, and PD merge left-right on equals key combines them based on the key column aligning rows with matching values. We generate a data frame with random integers and save it as a CSV file named foo.csv. Later, we read that file back into a new data frame, restoring all the data for further analysis or processing. We saved the data frame to an Excel file called foo.xlsx with a sheet named Sheet 1. Then, we load the data back, specifying the sheet, handling missing values, and not setting any index column. That's a wrap for working with Pandas. We've covered everything from data manipulation to saving files. In the next video, we'll bring our data to life with beautiful visualizations using Matplotlib and Seaborn. Don't miss out. Hit that subscribe button and get ready to dive into the world of stunning charts and plots.